The idea of venturing beyond Earth has fascinated humanity for centuries. But in the 21st century, exploration of the cosmos is no longer just a dream scribbled in science fiction. It's unfolding in real time. And guess what? Robots are leading the charge. Picture a machine landing on a distant world, braving freezing nights, climbing rocky slopes, and sending back stunning photos across millions of miles. No, it's not a movie trailer. It's reality, and it's only the start of what robotics will bring to the final frontier. Robotics has quietly become the backbone of space exploration. While people fantasize about planting flags on Mars, our mechanical pioneers are already there, scouting the terrain, sniffing out soil samples, and prepping the groundwork for future astronauts. Think of machines like NASA's Perseverance rover. Not just gadgets, but stand-ins for our own curiosity, designed to go where we can't, endure what we can't, and beam back secrets of the universe. They're basically our cosmic avatars, minus the need for food, air, or a good night's sleep. Before we dive deeper, don't miss a moment of the discoveries unfolding right now. Subscribe, like, and turn on notifications so you're always first to see where the future of exploration is headed. Let's take Perseverance as an example. Launched in 2020, it nailed a pinpoint landing in Jezero crater on Mars. Its mission, to hunt for signs of ancient microbial life. It's got cameras sharper than some movie directors dream of, tools that sniff out rock chemistry, and let's not forget Ingenuity, the tiny helicopter that became the first aircraft to fly on another planet. That little chopper was supposed to do just a handful of flights, but went on to become the overachiever of the century. And Perseverance isn't alone. Spirit and Opportunity, two earlier rovers, were designed for months but lasted years, becoming legends in their own right. So why do we lean so heavily on robots? Because space is not exactly welcoming. Distances are ridiculous. It can take months or years just to get somewhere. Communication signals move at the speed of light, but across those distances, even light feels sluggish. Temperatures swing between melt your suit hot and snap freeze your lunch cold. Radiation is everywhere. Oxygen? Forget it. And then there's the sheer bulk of everything humans need to survive. Food, water, breathable air. It's like trying to bring an entire grocery store and hardware store on vacation. That's why robots aren't just helpful. They're essential. They don't eat, they don't breathe, and they don't complain when conditions get rough. They can tough out radiation and operate for years on little more than sunlight or nuclear batteries. And best of all, they can fail without tragedy. Losing a rover is heartbreaking. Losing a human life is devastating. Robots are the scouts, the daredevils, the test pilots paving the way before humans set foot. So the big challenge becomes, how do we make them smart enough to explore on their own? The latest generation of space robots gives us a glimpse. Europe's Rosalind Franklin rover is designed to drill deep into Martian soil to hunt for preserved biosignatures. NASA's Dragonfly mission will send a nuclear-powered rotorcraft to Titan, Saturn's biggest moon, to hop around and explore its methane lakes and icy dunes. Meanwhile, China and India are proving this isn't just a US-Europe show. Their robotic landers and orbiters are turning space exploration into a truly global effort. But even these marvels are just Act 1. The real plot twist comes when robotics teams up with artificial intelligence. What happens when machines can learn, adapt, and make decisions faster than humans could ever relay from Earth? That's where things get wild. AI-powered robotics could change the entire game. Instead of waiting for Earth's approval, machines could act in real time. Picture a robot spelunking through the icy cracks of Europa, Jupiter's ocean moon, while making split-second decisions. Imagine swarms of small bots on Mars working like ants, building shelters before astronauts arrive, or AI systems running life support, mining ice for water, or handling emergencies, all before humans even leave the launch pad. In short, these robots could be the forward crew, setting the stage so humanity arrives to find a ready-made welcome mat. NASA and its partners are already experimenting. Machine learning is being trained to spot geological features faster than human eyes. Rovers are learning to drive themselves over unpredictable landscapes. Studies in journals like Nature Astronomy suggest that autonomy isn't a bonus, it's a necessity. If you're sending a probe out to the far reaches of the solar system, waiting for instructions from Earth isn't going to cut it. AI may end up calling the shots when split-second choices mean mission success or failure. Here's a quick pause. If you're fascinated by how far this could go, make sure to subscribe, like, and turn on notifications so you don't miss the biggest leaps as they happen. And it's not just government agencies. Companies like SpaceX and Blue Origin are moving fast. envisioning robotic construction crews setting up bases before people arrive. Imagine humanoid robots on the moon doing the heavy lifting, fixing equipment, or handling emergencies when astronauts are busy elsewhere. Some prototypes designed for disaster response here on Earth are already being adapted for space. Meanwhile, mining bots could harvest lunar soil or extract valuable metals from asteroids, kickstarting an off-world economy. Talk about robots paying for their own ticket. In this vision, robots aren't just explorers, they're partners. In some cases, they could even be the first colonists. They might build infrastructure, process resources, and leave humanity with a head start. The first astronaut to step onto Mars might find greenhouses already sprouting or water tanks already filled, courtesy of their tireless robotic co-workers. If that happens, we may have to start throwing thank you parties for robots. Of course, this comes with risks. Autonomy can be a double-edged sword. A glitch in the code could tank a billion-dollar mission. One wrong move and years of planning go up in cosmic smoke. That's why engineers build in layers of fail-safes, redundancies, and backup systems. Robots may act independently, but they'll always need a safety net. After all, the last thing we want is a rogue robot trying to freestyle in deep space. And then there's the deeper question. If robots are the explorers, the discoverers, even the first builders of extraterrestrial outposts, what does that mean for us? Are we still the pioneers, or are we outsourcing the job? The likely answer is partnership. Humans bringing creativity and vision, robots bringing endurance and precision. Together, the team can do far more than either could alone. Some thinkers even suggest robots will redefine what it means to explore, since they blur the line between being just a tool and being an active participant. The future of exploration isn't a humans versus robots showdown, it's a humans and robots buddy story, one with the cosmos as the backdrop. Now back to the story. NASA's Artemis program is gearing up to return humans to the moon, but the supporting cast? A whole suite of robots. Landers, construction bots, and autonomous supply systems will all play critical roles. Picture robots laying out solar farms across the lunar surface or carving out tunnels in the regolith to create underground shelters. A permanent moon base may owe as much to robotic hard hats as to rockets. Meanwhile, Mars sample return missions are in the works, requiring flawless choreography between multiple robots, one to collect samples, another to launch them into orbit, and a third to ferry them back to Earth. It's like a robotic relay race with stakes higher than any Olympic gold medal. The goal? Answering one of humanity's biggest questions: did life ever exist on Mars? And we're not stopping there. Future plans imagine probes diving into Jupiter's stormy atmosphere, enduring pressures that could crush a submarine. Fleets of autonomous sensors might map the asteroid belt, sniffing out valuable minerals or piecing together the history of our solar system. Japan's Hayabusa missions, which already snagged asteroid samples, show us that this vision isn't just science fiction, it's already beginning. So where does that leave us? On the edge of a brand new era. An era where humans are less lone adventurers and more the conductors of a grand symphony of machines. Some robots will play solo, others will harmonize in groups, but all together they'll orchestrate the greatest discovery mission in history. The stakes are enormous. What we discover could redefine our understanding of life, the universe, and our place in it. Resources from asteroids could spark entire industries. And technologies built for robots in space are already improving life back home, from medical devices to agriculture to climate science. Who knew Martian rover tech might one day help monitor Earth's deserts or protect its polar ice sheets? At its core, the story of space exploration has always been about innovation, about taking risks, testing limits, and reaching farther than we thought possible. Robotics isn't just another tool, it's the spearhead of that mission, the trailblazer making the impossible possible. And the big question remains, how far can this partnership go? Could robots one day carry not just sensors but seeds of human civilization into interstellar space? Could they terraform worlds or create habitats where life has never existed before? The possibilities are as vast as the universe itself. Robots have already shown us Mars's rusty plains, Enceladus's icy geysers, and the far edge of interstellar space. With AI, they might soon reveal mysteries we haven't even imagined. The journey has barely begun. So, as we wrap this up, remember, the future of exploration won't be written by humans alone. It will be co-written by us and by the machines we've created, working side by side among the stars. What do you think? Will robots remain our scouts or become something more, partners, builders, maybe even cosmic roommates? Drop your thoughts in the comments. And for more deep dives into the cutting edge of exploration, subscribe, like, and turn on notifications because the cosmos is calling. This is Tech Mythos.